18 of Neetcode 150, permutation in string. So in this problem, we are given two strings. Um, the first string that is supposed to be smaller than the second one. And we want to know if the three characters or the four characters or whatever the number of character is in the first string appears next to one another in the second string. They don't have to be exactly in the same order. We don't have to see A, B, C, but we need to see the three characters next to one another. So it can be C, A, B, it can be B, C, A, whatever. Here it is C, A, B. It's fine, it works. So we have a permutation in the string. For example, here we have RTS, and in the other string we have SRT. We can see that the characters RT and S are next to each others in the second string. So we have a permutation. But below we can see that if S1 is CPZ, we don't have these three characters next to one another in our right string, so we do not have a permutation. So how can we solve this? The best technique is to use the sliding window. So the first thing that we want to do is we're going to create an array with 26 zeros. Each zeros is going to represent a letter in the alphabet with its count. So initially, we're going to have 26 zeros because we didn't start looping through any strings yet. But the first thing that we're going to do is that we're going to have a window that is the length of the first string. So here the first string has a length of 3, and we can see that our window here, the golden square, has a length of 3. It takes 3 characters of the second string in. And what we're going to do is that we're going to want to increment the count of the specific characters that we have in both strings. So for example, if we go ahead and do the S1, we have X, B, and C. So we're going to increment by 1 the value at B, C, and X. Okay. And we are going to do the same thing for the first 3 characters of S2. So in this case, we have R, K, and S. So let's go ahead and add 1. Great. So now we know which values are in the first string, and we know which values are in the windows of the second string. And we want to know how many characters matches, basically. So a match doesn't have to be 2, 1. It can be 2, 0. It can be 2, 2. So if we take just the A here, we can see on both sides, the A has a value of 0. So this is a match. Now the B of S1 has a value of 1. The B of S2 has a value of 0. So this is not a match. The C of S1 has a value of 1. The C of S2 has a value of 0. So this is not a match. And we can see that we currently have 20 matches. So I'm just going to write it down here. Okay. So we have 20 matches right now. And what we're going to do, we're going to move our window by 1 to the right. We can see that now we are including another character. So we are including U. And basically after this initial stage where we add the characters of S1 in the array, we are not going to touch the array of S1 anymore. We are only going to touch the array of S2. And every time we are usually going to increment the count of the index of the new characters and decrement the count of the index that just left the window. So here we are going to add 1 to U, and we are going to decrement R by 1. Okay, so now we also want to check what the matches are. Well, we can see that we now have a new matches at the R value, as the R value of S1 is 0 and the R value of S2 is also 0. But we also remove the match, right? So both U used to be equal to 0, but now the U of S2 is equals to 1. So we created the match, but we also remove the match. So I removed the 0, but we are still at 20 matches. It didn't move. So we are going to move our windows again. We're going to add B now. B is now inside the window. So B is now 1. And we can see that it is actually matching with the B value of S1. So we have a new match. And we're going to decrement the value of K by 1. All right, so K is now going to be 0. So now we can set both B's are 1. This is a match. Both C's are not the same. All right, which are our other mismatches? All right, both S are not the same. Both U are not the same, and both X's are not the same. So we now have 22 matches, which is getting closer to 26. And you might have guessed it, but if we actually reach 26 matches, it means that every single characters of the S1 and the S2 are the same. So we do have a permutation, in which case we are going to return true. Okay, so we are going to move our windows again. Basically, we're going to move our windows until we reach the end of S2, or we have 26 matches. So, all right, in this new window, we are adding X. Okay, so X is now 1, and we are removing S, or we are decrementing S by 1. So now both X are the same. The only mismatch are the U's. And there is no other mismatch. The only one is the U. So we are currently at 24 matches, which is getting closer to 26. All right. So we are going to move our windows again, and this time we are adding a C. We are adding C to the S2. And we are removing U, which used to be a mismatch. So now if you check for every single indexes of the S1 array and the S2 array, you will see that the value at each indexes is exactly the same for both arrays, meaning that we have a permutation and also 26 matches, right? So this is exactly all we are going to code this. So let's go ahead and write the code. All right, so first thing we want to check is the length of S1 greater than the length of S2, in which case basically permutation is not possible. So if the length of S1 is greater than the length of S2, we're going to return false. All right, and after this, we are going to create our two arrays. So we're going to create S1 count and S2 count. And the way to do this is basically an array of 0 times 26. So we're going to get an array with 26 zeros, which represents the count for each letters in the alphabet. And now if you remember in our example, we first took the characters of S1 and we added 1 to the value at the index of the characters in string. And we did the same thing for the first 3 characters of, well, I say 3, but the first X characters of S2, X, which represents the length of S1. So we are going to do this by having our for loop. So for I, so we want a for I in the range of basically the length of S1. Okay. So what we're going to do is that we're going to increment the S count at the index of that character. So the question here is, how do we get the actual index? For example, if I have C, how can I say this is index 2, right? Because it has to be the third number in the array. But how do you get that index 2? Here we are going to use the ASCII value. ASCII value, basically, is the value of that character, and it is going to, for example, the lower A, I think it's 97. Lower B is 98. Lower C is 99. So if you take lower C, the ASCII value of lower C, 99, minus the ASCII value of lower A, you're gonna get 2, which is actually the index that we wanna get. So we are gonna say ord, which is gonna give us the ASCII value. You want to take basically the the number of S1, or the character of S1 at the index I, whatever this is. And we want to remove this by the ASCII value of lowercase a. And we are going to do the same thing for S2 count. We are going to take the ASCII value of the string 2 this time, also at index I. And we're going to remove the ASCII value of lowercase a. All right, so at this time we have our initial array set up, and we are ready to move to the second round, which is basically to initiate the matches. So first, the matches will be equal to 0. And now we will go through every single numbers in our array. So if they are the same, we're gonna add 1 to the match. If they are not the same, we are just gonna let it as 0. So for I in range of 26, right? We have 26 letters in the alphabet. We're gonna increment matches by now we're gonna add our if statement. So by 1, if basically the value of the character at the not index 1 but at index I of the S1 count is basically the same as the one at the index I of the S2 count. All right, and otherwise we are just gonna let match as it is. Great. So now we can start building our sliding window. A sliding window will need first a left pointer, which is gonna start at the index 0, and our right pointer is gonna basically start at the end of the first string. So we want to have our left windows, which includes the index 0, and since we want x amount of characters, x, which is the length of S1, we are going to do as follow. So for R in the range starting at the length of S1 and going up to the length of S2. Okay. So now we are in our sliding window algorithm. First thing we want to check is what is our current match? Is it 26? If yes, return true. So if matches equals 26, we want to return true. All right. And after this, what we're going to do is that we are going to add to S2 count. We're going to add 1 to the value of the character. So if we add a C in the window by sliding to the right, we want to add 1 to the count of C. So first we have to take the index of that new character. And this index is going to be found using, once again, the ASCII value of the string two at the right pointer. And we're going to remove the ASCII value of lowercase a, just like this. And we are going to add 1 to s2 count at the index that we are at. Great. And now there are two scenarios. Let's say that in our S1 we added a. So the a count in the S1 array was 1, but we don't have an a in the S2 yet. But by moving the windows, we now include a 1. So let's say that the initial count of a in S1 was 1 and the initial count of a in S2 was 0. And now we add 1 to the count of S2 at the position of a. Well, basically, both a will be the same. So if we create a match, we're going to have to increment matches by 1. So we're going to say if the S1 count at that index is equal to the S2 count at that index. In this case, we want to increment matches by 1. Another scenario is that we used to have a match, so a and, well, both a were 0, for example, but now we added a, so the a of S2 is now 1, meaning that the count of a for S1 is 1 less than the count of a for S2. So in this case, we broke a match. So if S1 count at the index plus 1 is equal to S2 count at the index, we want to remove 1 to matches. All right. And now the same logic is going to apply for the left index of the window. So when we pass a character out of the window, so instead of S2 R, we're going to use S2 left to find the index of the character that is no longer in the window. And now instead of incrementing its count, well, it is no longer in the window, so we're going to decrement it. And if by doing so, the count of S1 at that index is the same as the count of S2 at that index, well, we have to match, we have to increment match by 1. Otherwise, if they were a match, but now you decrease the, for example, if you both have, for the value S, for example, S1 is 1 and S2 is also 1. But now you remove 1 to the value of S in S2. So S of S2 is now 0. Well, it must mean that you broke a match. So instead of adding 1 to the count of S1, we are going to remove 1. And we're going to also decrement the match because we just broke the match. And at the end, we want to move our left pointer by 1 to the right. Okay, so that's pretty much it for the algorithm. We first check if the length of S1 is greater than the length of S2. If it is the case, we return false. Then we create our S1 count or S2 count, which are arrays of 26 zeros at first. And now we are going to go over the first characters of S1. And we're going to take, we want to see what are the first same characters in the S2. Just like this, by using the ASCII value. And then we want to create our match. So match is initially 0, and now we're going to go through every single characters, every single values in the array, and we're going to add 1 to match if basically the the count at S1 is the same as the count at S2 at the same index. Otherwise, we are going to return false, or we're going to return 0. And then we have the logic for the sliding window. So we're going to run or write index starting from the end of S1, going to the end of S2. And if the match is 26, we are going to return false. And after this, we have our logic where we take the index of the new characters that we bring inside the window, and we add 1 to it, and we check if by adding this index we created a match, or if we broke a match. And we're going to do the same thing for the characters that is no longer in the window, so the one that is that used to be at the far left. So if we created a match, we're going to increment the matches by 1. Otherwise, we are going to decrement the matches. And at the end, if we reach the last characters, we are not going to go back to the for loop. So we are not going to reach this if statement here, if the matches are 26. So we can't return false by default. So we are going to have to return matches equals 26. And that's going to do the job for us. So that is the algorithm using sliding window. And we have a wrong answer. So I just want to check real quick. So we are checking if S1 is smaller than S2. We're creating S1. We're creating S2. All right. Matches. We are creating the matches. True. So where is the error? Okay. This one. Index. All right, it seems good up to here. I probably did a typo somewhere. Matches. Okay. So this is unexpected. So we are checking if the length of S1 is greater than the length of S2. If it is, we return false. We set our 2 arrays of 26 zeros, and we're gonna go for I in the range of S1. We are gonna basically add. Oh, okay. Here's the problem. Is that I didn't incremented the value here by 1. I apologize for this. Okay, so yeah, so this is how we use the sliding windows to solve the problem permutation in string. So I apologize for the error here at the end, but still I hope that you learned from this video, and I hope to see you in the next one.